Alright lads, I'm just going to talk to you a little bit about angle A, which is standing on the circumference, being half the size of angle B, standing at the center of the circle. So firstly what we can do is we can draw a line through point A, or starting at point A, straight through B, and we'll continue it on to the opposite side of the circle. Or you can go the other way, like so. And then what we're going to do is we're going to mark in equal lengths. So this is the same, this is the same, this is the same. Now you could mark here, but there's no need because it's not part of our original shape. So if we look what we have at the minute, we have two separate isosceles triangles. So if we just block it off here, what we have is this here is point A, so point A is still up there. Point B is in the center, and if you could call this point C. So two equal lengths for two sides means that angle C and angle A are going to be the same, so we're going to call them angle 1s. Okay? And then in the center, we're going to stick that in as angle 3. You'll see that why in a minute. If we go back over to our opposite triangle, and we have the same lines with the same length, so two sides of equal length, in triangle A, B, C is on there, so we're going to call this one D. These are going to be equal angles, or equal size of the angles in the corners of our isosceles triangles. So angle 2. We're going to call the angle at the center 4. Then we're going to call this angle here 5, and this one here 6. So for the minute, we're just going to talk about our first triangle, which is ABC. We're going to talk a little bit about the maths behind it. So in isosceles triangles, we have two sides of equal length. We're going to have angle 1 plus angle 1 is equal to angle 1. Okay? Angle 2 is equal to angle 2 in our opposite isosceles triangles. Now this is because they are isosceles triangles. Okay? We can assume that because it's an axiom. Okay? Now, as we know, all triangles have 180 degrees in them. So angle 1 plus angle 1 plus angle 3 will be equal to 180 degrees. Similarly, a straight line is 180 degrees. So angle 3 and angle B will be equal to, angle 3 and angle 5 will be equal to 180 degrees also. Okay, so that's this straight line here. We can assume the same for the opposite side. So our opposite isosceles triangle. So angle 2 plus angle 2 plus angle 4 is equal to 180, and angle 4 plus angle 6 is equal to 180 degrees. Okay, so we're going to talk a little bit about how angle 5 is twice the size of angle 1 here, because we know exterior angles, which is exterior angle on a triangle, which here is angle 5, is the sum of twice the interior opposite angle, which is angle 1. So if I say 2 times angle 1 is equal to angle 5, which is the same for the opposite side. So 2 times angle 2 is equal to angle 6. Yeah, so we're almost finished. So if we go up here and look at the top again, we have angle 1 and we have angle 2. So 2 times angle 1 is equal to angle 5, which would be this half here. And 2 times angle 2 is equal to angle 6, as we said here, which is going to be this side. So that means twice angle 1 and 2 is equal to angle 5 and 6, which proves that angle B, which is the center one again, is twice the size of angle A. Okay, so angle B is twice the size of A, which is proven by 2 times angle 1 plus 2 times angle 2 is equal to angle 5 plus angle 6 plus angle 6, which is the same as saying 2 times A is equal to B. Thanks for watching, guys.